happy to answer it. So yeah, we'll just cover why do we use Go, how we use it at NextJump, and then we'll go over structs, interfaces, and then concurrency. Cool. So I'll hand over to Klein.
Yeah. Hi everyone. So I'm here to talk to you about why did we choose to use Go, and also hopefully it's also to explain why should you choose to use Go in your application. So as you might know, Go was released by Google in 2009, and it has been over a decade since, and it has become a very popular language. And just to go, why did we choose to use Go at NextJump specifically? Is we found there are two things. The first one is that it makes our life as developers really easy. And what I mean about that is, as I talk more about how Go enforce formatting, it's also there's usually just one way of you doing, let's say a for loops or writing code. So you spend more time trying to write code, try to figure out how to go about developing your application instead of arguing about code. And it's also actually I let you build very fast system. So you might know Go is quite low level, and it's like C, C++. You are able to compile. And it lets you run the application really, really fast, and it also helps you, there's some features that makes it really safe. And so, as I said before, it lets you focus on building better products and not arguing about language problems. I remember the first time I come to NextJump, and I was given a task to actually debug a bug on our Go system, and I was freaking out, and I really don't know what's going on, but taking a look at the Go language is actually quite simple to understand. It's very close to Java if you have used them. It's also quite close to C++, and I was able to read it really easily and understand it very easy. And so just don't take our words for it. So since it's released around 11 years now ago, Go has been one of the search term has grown quite steep over time, and in 2017 it's actually in the top 5 most popular, most loved language in the world in the Stack Overflow developer survey, and so there's some credits there for Go. So going through on why how is it easy to learn Go. So it's actually quite a minimalist language with very small set of features. What I mean about this is usually just have one way of doing things. So a very, very good example is, as you can see on the right-hand side over there, there are around 4 ways of you doing a for loop in JavaScript. But in Go, there's actually only one way, and that is for range. And you just cannot find another way of doing that. And so so you might be wondering on why Go is so strict on doing this. So the story goes is when Go was developed by Google, it was at the time when Google also onboarding a lot of new engineers to the company, and when they designed the language Go, they also focus on how can we help these new engineers learn all the good coding practices, and so so you will find out that Go is actually quite we call it opinionated language. So they really strict on it doesn't let you compile when you don't do things that how it likes you to do it, and it actually helps me learn how good coding practices, and I'm sure it has helped Google engineers on developing their skills. And so as I talk about Go, so one of the things that I found really helpful for myself is actually Go FMT. So I'm quite OCD when it comes to my code. I used a lot of Python back when I was in college, and as you might know, there's tabs, the argument between tabs and spaces, and then it's and then sometimes you write C++ code, you're like, oh, do you even indent your code at all, or how do you do it? And Go let you do that very easily by just type Go FMT and your Go file, and then we just format all your code to a single formatting standard. And if you use a code editor like Visual Studio Code, whenever you actually save your Go file, it actually also format your code for you, which is really handy. And it's so talking about why Go is really it helps you to develop really fast, really efficient application. As you can see, Go was designed with web application in mind, and you can see when you build a web server, Go there's very little layers in between you and also the operating system. So when you compile your code, it's a very low level code, and you are able to let your code run really fast. Compared to other languages like PHP, Java, and Python, Go is actually much lower level than all of them. And if you can see here is a chart of the runtime. So Go is a compile language. So you compile, you'll be garbage collected. And then you can see like on the graph on the bottom right, you can see Go comes out like neck and neck with C in how fast it can run. And so I'm not going to go too much into like the theory. James has like some awesome tutorials, some hands-on coding. So I just go through very quickly some more features of Go, just to let you know like how awesome it is. It's also very strict on error handling, and usually error handling is not usually taken very seriously. Especially me as a new developer, I was just like, it's okay. Like, let it die, you know. Like, and I don't need to handle errors. But Go actually very strict on error handling. Like you have to handle errors whenever you return a function, and in this way, it actually forces you to think of like how you're handling these bugs, and actually helps you think more critically on what your application would do if an error comes up, and actually helps you to develop an application with fewer bugs, hopefully. And yeah, and it's just like what I say, it's very opinionated language. It's like if you don't handle the errors, when you compile, it's like, oh, your errors is not handled. So James will talk more about concurrency with you, but it's actually one of the reasons why we chose to use Go initially at NextJump. So we're actually building a lot of microservices. I think it was for the cinema app. Was it? Yes. So for the cinema app, so you imagine we're selling tickets to like thousands of people in 1 minute, and we need to handle a lot of concurrent requests from the client. So we actually, when we designed it from the ground up for our system, we chose Go deliberately because it has very simple ways of doing concurrency. I know from Python it's just a nightmare to do concurrency because it's like, how do you even do it? It's like and if you do it with other languages, you need to like worry about resources, like sharing resources. What like I'm sure you have learned about like logs and semaphores and everything in college, and Go actually make it very simple with channels. So James, I'm not sure we'll go through channels in this talk, but how it is channels is like a channel of data, and how you like interact with data is through channels, and it makes like managing resources with concurrency really simple. So how James has touched on that briefly in the first part of the talk is how do we use Go at NextJump. So historically, we built our application, our e-commerce platform on PHP. So we do a lot of database requests in PHP. But as we develop our application, it just become a nightmare with you call database as one source, and then you just so we want to do it's called you try to separate out the service layer and also the front end. And using Go, we are able to have all the database call within our service layer, and we build our application as an API endpoint when our front end can just quickly call our Go service to quickly grab all the data that we need. In this way, we are able to, so it's actually a very good practice in engineering for you to decouple your system. So yes, so decouple your system. In that way, you can able to, it's help us to debug our our system much faster and able to see to develop our system much better. And so I won't hold you back any longer from the hands-on tutorials that James is going to give you guys. So,
Cool. Okay, cool, thanks. So any questions so far? Any thoughts on that? Okay, cool. So this isn't live coding. I'm just going to show a screenshot, and then we'll do more live stuff with the concurrency. So just very quickly so you can read the syntax. So if you want to do a hello world in Go, it just looks like this. If you have a function called main, that's the entry point of your program. It's just like C, so func main. We then have a FMT. This package allows us to print stuff and handle text. So we're doing FMT, printf, hello, and that's world in, I think, Japanese. Someone correct me if I'm wrong. But the point I'm making here is that Go supports Unicode by default in strings, which is quite cool if you want to handle different languages, you want to handle emojis and code, stuff like that. So the biggest question people ask about Go is it an object-oriented languages? And essentially, Go doesn't really have objects. It doesn't have inherency. It is a totally different method for handling that kind of stuff, which I'll go through in a little bit more. I'm not going to go through the theory of this, but if you're coming from a background which is more Java-based, where you kind of extend classes and you have inherency, Go doesn't work like that at all. It uses things called interfaces, and all you have to do is conform to an interface, and you become a type of that class. So you don't inherit stuff. An example of this is it's the difference between is-a and has-a, but I'm not going to go through the theory too much here because I think it's better just to show how it works. So how we mostly do this is through structs. So I'm going to jump into cool. Okay, so could everyone read that, or does anything make it a bit bigger? Bigger? Yeah, cool. Not big enough? We're bigger? Anyone want to go bigger? I'll take one more call for bigger. Okay. All right. Cool. Okay, so this is a really simple toy program. So I'm using Golang, which is a editor made by IntelliJ. So I really like using this. It has a lot of built-in stuff for Go, which is quite nice if you're curious. So essentially what we're doing here is we're trying to calculate the area of a circle. So the first thing I'll point you to is we have our main function. So this is going to be the entry point of our function. We then defined a struct. So we've essentially made a new type. So you do type, we called it a circle, and it's a struct. And a struct is just a collection of values, or attributes, right? So we defined an x, a y, and a radius as well, all type float. So it's pretty easy to read. And we can make a new circle just by saying C is a new circle, and we define it by setting x, y, and r. That's all pretty simple stuff. And then we've defined a function called circle area, which takes a circle struct and does some math and returns it. Okay, so we can just run this. There we go. So no surprises there. So the key point to point out is that we built these things called a struct, and a struct has our attributes on it, and we can make new structs. Okay, so I can make another circle here. I can make circle 2, which has a radius of 100. Make another one. Okay. Just ignore that. Oop. It's live coding. Okay, so pretty simple stuff there. So what I was talking about earlier around classes and how do we do objects in Go. So this is a really simple example of what I mean by that. So we've defined our struct, circle, but on structs you can also define functions. Okay, so this, if you're thinking of like a Java comparisons, imagine you make a class, and your class has some attributes. You'd have like a circle class that has an x, a y, and you might have a function on that class. You can do like circle dot calculate area. The way that looks in Go is a little bit different. So there's a bit of some funky syntax here, but once you read it, it's okay. So we're defining a function on a circle called area. These are called receivers. So I'm going to use that word receiver. So it's a function on a circle called area. So now when I make a new circle here, I can do c.area. So because that's defined, it's a thing that's defined on the struct. and then that'll return me a value. So same thing. So this is a slightly neater way of doing it. So rather than writing functions that take a circle, you just define functions on a circle itself. So say I wanted to make another thing on a circle. Say I wanted to do something which was like, say how, like, tell me the radius. I could do like, tell me, this is a really silly example, but return c.r. So the benefit of this syntax is I'm actually accessing, when I do c.r, I'm accessing the struct's value of r. So I could do r, tell me radius, that. And that. Okay. So the takeaway of this is we can define functions on top of structs. Okay, so this is a really core part of Golang. All right, we're going to come back to why this stuff is important in a second. Are any questions so far? Is everyone following? Okay, you can come up and ask us questions after if there's thoughts. Okay, so why is this interesting? So before I mentioned that we don't have classes, we don't have inheritance. We do a different thing called composition. So in programming languages, you can either do inheritance or you can do composition. Go does composition. So what I mean by that, we can define an interface. Okay, so what an interface is saying, we have a new type called shape, and anything that does an area, has an area function on it, is now a shape. Okay, so you can make any array of different types of structs, and so long as they do an area, it doesn't matter what else they do, as long as they have an area, they are a shape. So what do I mean by that? So let's go back to our example of a circle. So you've got our circle here, which is a struct, same as before. And exactly the same as before, we defined a receiver on that struct called area. But now we've also made a rectangle. And our rectangle also has this area function. So this means both the rectangle and the circle are a shape. Okay? Golang makes this easy to look at, so I can actually see what is a shape, and I can look at different things that do it. So why is this interesting? So this is interesting because we can now make a function that just takes an interface that actually doesn't tie it to a specific type of struct. So before, if I wanted to make a, say I want to make a rectangle. So we've got our rectangle class like that. Now I made a rectangle. I could do, so let's define a rectangle, x, y. What else do we need? W, 5, h, like 2. All right, so we just made a rectangle. We can do r.area. I'm hoping. R dot. Yeah, so let's define one. Oh my gosh. Rectangle, r, and let's just return x times y. I know that's not actually r dot x, r dot y. Okay, so now I can do r dot area, right? So that makes sense. But say I wanted to have a function that just took in any shape. I didn't care if it was a rectangle or a circle. I just want to calculate the area of any shape that I get. I wouldn't be able to do that because I'd have to say, I couldn't make a function which is like, I have to make a different function for rectangle versus area. But if I make them both conform to this interface, I can then make a function that looks like this. So total area just takes a shape. So what this means is take any struct, and so long as it does area, it can take it. Because we know that it conforms to this interface, so we can just loop over an array of shapes and then call shape.area. So this is a really powerful concept. It looks quite simple here. But this is pretty much how the entire Go ecosystem is built around this idea of interfaces, and then you can build any struct. And this rectangle could do everything else. So I can make another one, which is like, hello. Okay. This rectangle is still a shape because it does an area. But it also can do something called hello. And you can actually be a part of multiple different interfaces. So I can make another interface, which is like a hello man. does a hello, returns a string. And immediately you can see, oh, there is something which is this rectangle is a hello man because it does hello, but it's also a shape because it does this. So the reason why this is powerful is your rectangle can now be as many things as you want it to be. Your structs can be anything. They can implement as many interfaces as you want to be, versus if you were in Java, you couldn't extend every single, say you couldn't inherit everything. So this is it's a really powerful mechanism. So we can just press start, run. So we've just called total area. We've made a bunch of different shapes. We can just pass them to total area. So total area doesn't care if it's a circle or a rectangle. It'll just take anything that is a shape. Okay. So that is structs. Did all this. I'm going to go through the time stuff and go to concurrency. So what I'm going to show you now is how the concurrency model works in a basic sense in Go. So we're going to do this problem. This is a classic problem in computer science. So we want to load up a bunch of different websites. So we're going to load BBC, CNN, Guardian, and Reddit. So these are the typical kind of things I would look at in a normal day. Normally, if you wanted to load this, you'd have to load it sequentially, right? So the time this program would take to run that struct become? Let's do test. So there's our first one. 2 does the same thing. Or string. Turn T dot. Okay, so it looks like testing is both foo1 and foo2. So in this case, sure. It'd be interesting to see. Yeah. So if you could have a function which takes a foo2, for example, and then I'm just curious myself. Yeah, so it's both in that case. Yeah. Any other questions on Go or concurrency as well? No? Cool. Okay. Well, thanks very much, guys. Thanks for coming. I hope to see you all tomorrow with the most helpful hack. Cool. All right, we're done. Thank you. Is there another talk?